Hello guys, welcome to Ramta Solutions. Today we are looking at your grade 11 quadratic graphs. Without any waste of time, let's get into it. But before we really attempt them, let's remind you of what you did in grade 10. Okay, let's remind you of what you did in grade 10. In grade 10, you had y equals ax squared plus q, right? So you knew that this a talks about dilation. When it's positive, your graph is smiling, which we call a minimum graph. When a is negative, your graph is frowning, which we call a maximum graph. It's a maximum because the turning point has the maximum y value. It's a minimum because the turning point has the lowest y value, right? And you also spoke about this value being your y-intercept, right? It was also your vertical shift, right? It was also your vertical shift. Remember, you said when Q was positive, your graph was shifting up. When Q was negative, your graph was shifting down, right? And it was also giving you your range, right? While we are on it, our turning point in grade 10 had the coordinate 0 and Q, right? Our turning point had the coordinates 0 and Q. Now, this is all that you needed to do, or you needed in grade 11. And I should also add your axis of symmetry. Your axis of symmetry in grade 10 was x equals 0, right? Hence, the turning point is 0 and Q, right? Your domain for a parabola was x is an element of a real numbers. Your range was depending on the value of a. If a is negative, is positive rather, your domain would be y is an element of real numbers, and y is greater or equal to q. When a was negative, you would say y is an element of real numbers, and then y, let me highlight this, you'll then say y is less or equal to q. Remember, we have a video on everything you need to know regarding grade 10 graphs, right? Now let's get into our grade 11 work. Now for grade 11, we have our graph in this way. Let's say this for grade 11. For grade 11, our graph could be given in the form, let's say it's given in the form ax squared plus bx plus c. I will say this a, when it's positive, our graph is smiling. When a is negative, our graph is frowning. This represents the y-intercept, right? This represents the y-intercept. So this is all I can say right now. But before any waste of time, let me try to factorize this. Oh, not factorize. I want to complete a square. So simplify by completing a square. Simplify by completing a square. So we have y equals y equals ax squared plus bx plus c. Let's take a common factor to be a, because the a The aim is to have the coefficient of x squared to be 1. So let's do this. If I take a to be a common factor, I will be having this. Alright, remember, when you say this is a common factor, this multiplied by b over a, it'll be b. This multiplied by c over a, it'll return c. So this means our factorization is correct. Now, continuing, we say y equals a into x squared plus b over ax plus half the coefficient of x, which is b over a all square, minus the very same thing, half the coefficient of a all square plus c over a. Right? Now we have x squared plus b over ax plus b over 2a all square minus b over 2a all square plus c over a. Now we have a. Now we'll take this x and this part of the bracket. We'll say this is x plus, because it's a positive here, plus b over 2a all square minus, let me say b over 2a so that I don't confuse you. Right, and we have y equals a into x plus b over 2a all square minus, this is b squared 4a squared plus c over a. So we have we need to simplify this. So we have a into x plus b over 2a all square. Now I want to write this in this way, plus lowest common denominator here is 4a squared, so I want to call it 4ac minus b squared, close. Okay, minus b squared, close. Okay, this is me simplifying this fractions here. Right, when I simplify these fractions here, I get this. Right, oh, my mistake. This is not for ac, this is for a squared. This is for a squared, my mistake. This is for a squared. Okay, now as we proceed, we say y equals, because we have simplified everything, I can kill these brackets, the square brackets, so I'll say a times x plus b over 2a all square plus a times this fraction here, it'll be 4ac minus b squared all over 4a. So 4ac minus b squared all over 4a. Okay, all over 4a. Okay, so this is the part that you have seen. Now we then will be given a parabola that comes into this part. I will tell you, let's say let p equals b over 2a and q equals 4ac minus b squared all over 4a. Okay, therefore this means y equals a into x plus p all square plus q. So you are given your parabola in these two forms. Okay, you'll be given your parabola in this form, and in this form too. Okay, in this form and in this form too. Okay, so without any waste of time, let's then head to the next section. So what I'm going to look at right now, I want us to look at what we will term let me do this before maybe this I want to call it horizontal shift. Okay, this is horizontal shift, meaning it moves the graph from left to right. This, it's still the same thing that you said in grade 10, which is your vertical shift. Remember, moving your graph up and down. So when P is positive, your graph shifts to the left. When P is negative, your graph shifts to the right. Again, with Q, we said when Q is positive, your graph shifts up. When Q is negative, your graph shifts down. This is what you have been saying from grade 10. So here are the conditions. For all the graphs that you will come across in mathematics, the P's, the Q's, they represent the same thing. With regard to shifting, they represent the same thing. Okay, they will mean the same thing when it comes to shifting. When I say shift, I mean translations. Okay, when I talk of translation, they will represent the same thing. So even when you get to parabolas, when P is positive, it shifts to the left. When it's negative, it shifts to the right. Okay, all right. Now let's then talk about excess of symmetry. Let's talk excess of symmetry. When given y equals ax squared plus bx plus c, and when given y equals a into x plus p all squared plus q, your excess of symmetry will be x equals negative b over 2a. Okay, it'll be negative b over 2a. When given this, your graph in this form, your excess of symmetry will be x equals negative p. Okay, when given your function in this way, it'll be negative p. X will be negative p. So maybe I had forgotten something. Excess of symmetry is a line that divides the graph into two equal halves. Okay, into two equal halves. Okay, into two equal halves. So consider a parabola like this. It is also x value of the turning point. Okay, it is x value of the turning point. Okay, it is x value of the turning point. So this is the point we're talking about. Excess of symmetry will be this line here, right? This line, this half will be equal to this half. Okay, this half will be equal to this half. So excess of symmetry, what does it do? It divides the graph into two equal halves. And also it is a line. It is the x value of the turning point. Okay, remember, you can use this, you can find your excess of symmetry in either way. When given your graph in this form, your excess of symmetry is minus b over 2a, and when given it in this form, your excess of symmetry is minus 2. Okay, all right. Now we're going to look at turning point. We're going to look at turning point. What is a turning point? This is a highest or lowest value or lowest point on the quadratic graph. Okay, on the quadratic graph. Okay, it is the highest or lowest point on the quadratic graph. Okay, so if you have this graph here, this point here is your turning point. Allow me to write it in this way. If you have this point here, this graph like this, remember this one is where A is positive, this one is where A is negative. This point here is your turning point. It is the highest point of the graph. This one here is the lowest point of the graph. This is why when a graph is like this, we call it a minimum. This is why when it's like this, we call it a maximum. Okay? Alright. Now, finding your turning point given y equals ax squared plus bx plus c. And maybe let me use f of x. Let me just say f of x. I like it that way. F of x equals that, or given it in this form, f of x equals a into x plus p all squared plus q. Here you will say, remember I had said to you, axis of symmetry is the x value, right? I said to you axis of symmetry is the x value of the turning point, which was minus b over 2a. Now, this is an x value. Now substitute this x value into your given equation. Okay? Substitute your given x value, your given axis of symmetry into your equation, the equation of the graph, and you will get the corresponding y value. Okay? When you are given a function in this way, the turning point would be, if you remember, I said minus p is your axis of symmetry. From grade 10, this q was a y value of the turning point. So turning point, when you're given it in this way, when you're given your graph in this way, turning point is minus p and q. Okay? It is minus p and q. Alright? Now, let's look at domain and range. Let's look at domain and range. So, for your domain, I want us to look at a is greater than less than 0. Your graph will look like this. When a is greater than 0, your graph looks like this. So here, this is the domain. Domain is always x is an element of real numbers. It will always be like that. For a parabola, any x value you can think of will always return a corresponding y value. Now, for the range, when a is negative, you can say y is an element of real numbers, but y, look at it, it can take all y values that are down there until this value here, which is a q value. So it can take all values of q and below. Hence I'm saying y is less or equal to q when a is negative. Now, remember, domain, it does not matter a is positive or negative. Domain will always be x is an element of real numbers. Right? X is an element of real numbers. Now for this one, the range will be, remember, when we talk of the range, it can take all y values, but there is an exception. There is an exception. It can take all y values, especially the ones where q value and above. When it's like this, it can take all q values and above. So hence I'm saying y is an element of real numbers and y is greater or equal to q. You can imagine it. When it's smiling below q value, remember the y coordinate of the turning point is q. Below the q value, you don't have a graph, right? This is why we say our range is all y values equal to and greater than q. Greater than q, remember we're talking y increases upwards. Okay? Now this is how we rock. All right. Now let's look at finding the equation. Let's find the equation. So when we want to find the equation, we have two ways. Let's say given x-intercept, when we are given x-intercepts, let's say we have a graph like this, and I don't know, I'm going to call this point x1, I'm going to call this one x2. I will say f of x or y is equal to a into x plus x1 and then x plus x2. I want to remind you of something. If x value is negative, okay, let x1 or x2 be positive, and then if x is positive, the roots, when you look at the roots, if x is positive, you must let x1 and x2 to be negative. So I will give you an example right now. So let's say, example, you are given this graph here. Let's say you are given this graph here. This is 1, this is 5, and then there's a point here. We will call this point minus 1 and 12. Okay, minus 1 and 12. And we say find the equation. Remember what I had said to you. F of x equals a into, let me change the color maybe. F of x equals a into x plus x1, x plus x2. You remember, right? So now, when you look at it, here we have x equals 5, and here we have x equals 1. Here we have x equals 1, and here we have x equals 5. Agree with me that this I can write as x minus 1 equals 0, while this is x minus 5 equals 0, right? So I will say f of x equals a into x minus 1 and then x minus 5. We have another point here which is minus 1 and 12. So where there's x, I will put minus 1. Where there's y, I will put 12. So 12 equals a into 1. I think what I like doing is this. Before I do this, I like simplifying this. I like simplifying this because it makes things easier for me. This is a into x squared minus 6x plus 5. You see, now it's better. Now I will use that point. Let me go to the next line. I'll use that point. The point was minus 1 and 12, right? And where there's x we put minus 1, where there's y we put 12. So we have 12 equals a into minus 1 squared minus 6 into minus 1 and then plus 5. So we have 12 equals 12a. So as you can see, a equals 1, right? It makes sense for a to be equal to 1 because this graph is smiling. Therefore, I am expecting my a to be positive. Now, I will substitute this back to this expression. Where there's a, I put 1, right? So f of x equals 1 into x squared minus 6x plus 5. Now, what is f of x? F of x is x squared minus 6x plus 5. You see, now I have found the equation, right? Thank you. Now, number 2, if given turning point, if given turning point, use okay, let me say f of x equals a into x plus p all square plus q, right? So substitute your turning point values into this expression and use another point that is given to solve for the unknown. In this case, it might be to solve for a, all right? And you are good to go. That's how you will do it. Okay, that's how you will do it. All right, so I'm gonna give you an example on this one. Okay, an example on this one would be, let's try this one here. Let me see. Okay, let me put it here. This is 0. I will say the point here is 3 and the turning point is -1 and 6. So what I know, though this point is -1, I know for a fact excess of symmetry, remember what I had said to you, excess of symmetry is an x value, it is equal to -1. Check this out. I said excess of symmetry is x equals minus p, alright? So what is your excess of symmetry? It is -1, alright? So this means your p value is 1. And indeed, that's what I had said. Now check this out. You will say f of x, let me change the color. Oh boy. You will say f of x equals a into x plus 1 all square. Now this is the y value of the turning point, which we call q. It'll be plus 6. Now we have another point given. What is that point? 0 and 3. We have a point given 0 and 3. So where there's x we put 0, where there's y we put 3. So what is this? This is 3 equals a into 0 plus 1 all square plus 6. What do we have? We have 3 equals a plus 6. Now a equals -3. Therefore, f of x equals -3 into x plus 1 all square plus 6. According to me, this is correct. Why am I saying it's correct? Look at your graph. Your graph is frowning, right? Your graph is frowning. Now, when your graph is frowning, it makes sense, right, for a to be negative. Therefore, we are correct. Now, they can ask you what is the range of this function. The range of this function is y is less or equal to -6, right? It can take all y values except it can take all y values that are equal to and less than 6, right? Now this will be your range. Okay, this will be your range. All right, guys, so with this being said, this is all you need for your grade 11 physical sciences. Sure, for your grade 11 mathematics. Okay, for your grade 11 mathematics quadratic graph. Okay, see you next time. Bye bye.